Evening everyone. This is Tato, the physical science tutor. Okay, so I'd like to thank everyone who came to class today, everyone who participated. This is just a follow-up video. Okay, so I'm going to summarize what we couldn't finish up on acids and bases. Okay, so under the topic of acids and bases, we have acids. Forgive me a little bit, I cannot track down my mouse. Okay, I'm trying to figure out where it is. Okay, let me check. I think my mouse pad is not properly placed. Okay, we have okay, let me see. Back, it's not writing properly. Okay, yes, under I want to see my mouse pad. Okay, under acids and bases. Okay, there are a few things that you have to know. You have to know the Arrhenius theory or definitions. Arrhenius, yes. You have to know Arrhenius, and you also need to know lowry-bronsted. Bronsted. Okay. So now Arrhenius said that an acid. Arrhenius said an acid is an H3O plus donor. So Arrhenius said an acid is a substance that releases an hydronium ion in water, and a base is a substance that releases OH in water. Okay, now when we come to lowry-bronsted, this one says, okay, an acid, okay, this one says, okay, an acid is an H plus ion donor, and this one says again, an acid, a base is an H plus ion acceptor. Okay, now please note the difference. Okay, the other one says this is an H plus ion donor, the other one says, okay, this is an H plus ion acceptor. All right, now so now you need to know why do we normally perform our acid and base reactions. Okay, so now when you perform this one, so you have to know that the only substance that can neutralize an acid is a base. Okay, so now when you react an acid and a base, okay, and the base, the results must give you a salt plus water. Now when you refer to a salt, we not normally refer to table salt, or as normally as it is known as NaCl. So we do not necessarily refer to table salt. Any relevant substance that falls under salts is included in this terminology. Okay, now a proper example of this will be given. So for now, take note of the following reaction, because I am keen to do our acid, the conjugate acid base pairs. Now we have the following reaction. It's HCl plus H2O, then it gives this particular reaction. of H3O plus Cl negative. Okay, now I want you to take note of the following. Okay, take note of this. Yes, and this. Okay, and this. All right, and I want you to also take note of this, this, and this. Okay, now what you are seeing here, you are seeing what it is called the conjugate acid-base pair. It is called the conjugate acid-base pairs. Pair. Okay, when you talk about a conjugate acid-base pair, the only difference between the substances must be an H plus ion. Now, if you take note, look at the only difference between this and that one. This will be the acid, and this one will be the conjugate base. So in this case, this one will be the base, and this one will be the conjugate acid. This one. Now, the only difference between water and hydronium ion is an H plus ion. The only difference between hydrochloric acid and a chloride ion is an H plus ion. So the difference between substances in a conjugate acid-base pair is this. Okay, so that one you will need to keep in mind. All right, now I'm going to give you a list of strong acids in case you are going to encounter such elements tomorrow when you are writing. So when you talk about acids, the following are known as strong acids: hydrochloric acid, hydrofluoric acid, and for example sulfuric acid, H2SO4, and many more others. When it comes to bases, you have sodium hydroxide, you are going to have potassium hydroxide, you are going to have sodium hydride, and many more. Now I want you to take a look. Remember, earlier on we defined our acid and base bases according to Arrhenius and lowry-bronsted. Okay, so Arrhenius says an acid is a substance that donates hydronium ion in water, and a base is a substance that donates a hydroxide ion in water, OH minus. So now let us go to our acid and bases. So Arrhenius says a base is a substance that donates hydronium, hydroxide. So in this case, he is right about this ones because they all contain hydroxide. But what about this one? What about this one? What about this one? Here. This one doesn't want to do what I want it to do. Okay. So now I am here. I want to put a star. Okay. Yes, there. It's fine. So, okay. Now, in this case, Arrhenius is not correct because this particular element here does not contain a hydroxide, but it is also considered as a base. So, Arrhenius theory is limited to equations that happen in an aqueous solution, the ones that has a subscript of AQ always. Okay, but now when you go to lowry-bronsted, this one's lowry-bronsted says an acid is an H plus donor, a base is an H plus, a proton acceptor. In chemistry terminology we call this one again a proton donor, and this one we call it a proton acceptor. Okay, so that's what you need to know about acids and bases. And also you need to know there is a substance that can act as either a base or an acid. So such a substance, we call it an ampholyte. Okay, so yes. There is a substance called an ampholyte. So this substance, it can either as a base or an acid. Okay, so those elements or compounds that are capable to act as both an acid and a base, we call them an ampholyte. Alright, so what else do you need to know? Okay, I will want us to do some few questions on acids and bases that we are going to write about tomorrow, of which are calculations, and these are the key points that you didn't do today in class. Okay, so please guys, whenever I give you a question, feel free to pause a video, attempt the question first, and pause the video and see the solution. Okay, so let me write the question. I'm going to pause a little bit. Okay, so now we have a set of questions. The first question, it's from one of the question papers. Let me remove that. Okay, it says now define a base in terms of Arrhenius theory. Okay, so what does the Arrhenius theory says? It says a base is a substance that donates OH in aqueous solution. So we are talking about a substance that donates OH ion in aqueous solution or in water. Okay, now explain how a weak base differs from a strong base. Okay, so now we know that a strong base dissociates completely. Dissociates completely in water. In water or in aqueous solution, where else a weak base partially dissociates or partially ionizes in water. Okay, now they say write down a balanced equation for the hydrolysis of this one. Okay, now I want to move this thing a little bit up so that I can have space to write that. Okay, so now when you are writing the hydrolysis, you can say what's happening with this pen? Okay, now you have NaHCO3 in AQ plus hydrolysis, right? So this one is a liquid. I'm going to specify it. Then we have a reversible reaction. then we are going to have H2CO3 plus NaOH. So when they talk about hydrolysis, can you see that we are putting this thing inside water? So that is the hydrolysis. That is the hydrolysis of this thing. Okay, you can also write it without the salt part, but the only difference is that this one will be negative and this element will be negative without sodium. Okay, now the next question says oh, they said the balanced it. Did I balance it? Let me check. 1 sodium, 1 sodium, 1 3 hydrogen, 1 hydrogen 3, carbon 1, carbon 1, 4 water molecules, 4 water molecules. Yes, it seems balanced. Okay, now they say a learner wishes to identify element X in hydrogen carbonate. Okay, so we have this hydrogen carbonate and a certain element X. To do this, she dissolves 4 grams of hydrogen carbonate with an unknown element X in a 100 cubic centimeter of water. She then titrates. Important. She then titrates all of this solution in a 0.2 mole of decimeter cube hydrochloric acid solution. Methyl orange is used as the indicator during the titration. So guys, mind you, we titrate so that we can reach the end point, right? So the use of suitable indicators is for it to change color, well, in a specific pH scale. Okay, so we are going to give reasons why methyl orange is used very soon. So 7.4.1, they say calculate the pH of hydrochloric acid. So what do we have? We have the concentration of hydrochloric acid as 0.2 mole per decimeter cube. Right now, 7.4 is 0.1. So to calculate this pH, technology, yes. So pH is equals to minus the log of concentration of hydronium ions. Okay, so which is equals to negative log concentration of that, which is 0.2, which is equals to what? 0.7, right? So this question, I think it was 3 marks. You get a mark. Gonna get a mark for substitution, get a mark for formula. Straightforward. Give a reason why methyl orange is a suitable indicator in this titration. Okay, so if you can check this titration, we are titrating what? A strong acid and a weak base. Okay, so if you titrate a weak base and a strong acid, the solution pH, the pH of the solution will be acidic. Okay, so 7.4.2. Firstly, the reason is the fact that you are titrating what? A weak, it's EAK base and a strong acid. A strong acid. I don't know what's happening to this pen. Okay, so since you are titrating a weak base and a strong acid, your pH will range somewhere here, of which this is a pH scale for methyl orange. Hence, we used that indicator as a suitable indicator. Okay. Now at the end point she finds that the balanced equation for this reaction is, so it's not included there, I'll have to include it now. Alright, let's see what I can do. Is do not browse through my gallery, please. Okay, now I want this one. Let's see, go away. I want you. Okay, I hope now it is visible enough. I hope this is visible enough right now. Now they say, let me move you down. Please don't talk about the answer. Now they say give a resin Y methyl orange. Okay, we answered this one. At the end point she finds that 20 cubic centimeters of the acid neutralized all the hydrogen carbonate solution. The balanced equation is this one. Okay, identify element X by means of calculation. So our purpose right now is to identify element X by means of what? Calculations. Okay, so we are given a balanced equation there, so there's no need for me to rewrite it again. So right now we were given the concentration of hydrochloric acid, so I'm going to use this equation, C of HCl equals to N over V. Okay, so C of HCl, it was given at 0,2, which is equals to N over V. Alright, so now when I want number of moles of HCl is equals to 0,2 times the volume. Okay, so the volume it was given here is 20 cubic centimeters. So I'm going to have I want number of moles, right? So I'm going to have 0,2, it's this one, concentration multiplied by volume, which is 20 times 10 minus 3. It gives me this times this, 2 times 2 will be 4, 0,4, I think. Let's me calculate. Not so good with calculations anymore, huh? So it's 20 times 0,2, which is 4. Okay, so I am getting not 0,4 but I'm getting 4 times 10 exponent minus 3, so it is in mole. Okay, now I have number of moles of hydrochloric acid. Now according to the balanced equation, number of moles of the hydrogen carbonate with element X is the same as number of moles of hydrochloric acid. Okay, and of which is equals to how much? 4 times 10 exponent minus 3 moles. Okay, so all this information I'm taking it from the balanced equation. There is no magic performed. All right, let me check. I want to do something here. My pen is too thin. Okay, so now we can use the equation of N is equals to m over bigger M. Okay, so now since I want for molar mass, so molar mass of which is bigger M is equals to M over N, which is equals to what? Is it? Let me check. I don't want to write wrong values. So somewhere up, how do you the entire thing? I believe somewhere up there, something we're given the mass. Okay. Yes. The mass of hydrogen carbonate with an X is 0,4. It's 0,4 grams. So now we are going to have 0,4 grams divided by the number of moles, of which is 4 multiplied by 10 minus 3, which will give us this. It's a 1000 equals there times 0,1, so it should give us something like 100 grams per mole. Okay, now we have the molar mass of the entire thing here. We have molar mass of the entire thing here. Okay, so what do we do now? Since we have the molar mass of the entire thing, we are going to say the molar mass of X hydrogen carbonate, okay, it's 0.3, is equals to molar mass of element X plus molar mass of HCO3. So where am I taking all these guys? Ne? Since I can find this, I decided to split them. Okay, molar mass of this alone, molar mass of this alone. I'm going to perform additions. It's the same as this. Inside this one is the same, but these ones, they are known, so I'm separating them so that I can be able to determine, right? So molar mass of this one, it is known. Okay, we found it there. So we have 100, which is equals to molar mass of element X so element X, okay, plus molar mass of this one, it's 1, okay, plus 12 plus 3 multiplied by 16. Okay, so we have 1 plus 12 plus 3 times 16, I get 61. Okay, so this one is equals to 61. Now 61, I'm going to move it to this side, so I'm going to have 100 minus 61, which is equals to molar mass of element X. Alright, now molar mass of element X is equals to, if you take the difference there, you get 39 grams per mole. Okay, so you can now go to the periodic table and conclude that therefore X, element X, is equals to K, which is what? Potassium. Now let me check if we answered the question. Yes, you answered. Identify element X by means of calculations. So we have determined element X by means of calculations, guys. So in summary, when you're dealing with acid and bases, you must be able to determine titration. Okay, you must be able to determine to neutralize an acid or a base using Savannah. Savannah is that formula of AVANA, okay, and then divided by CBVB over NB. So Savannah. So we must be able to use this equation. We must be able to determine which one is limiting, which one is not limiting, things like that. You must be able to determine pH scale. You must be able to determine pOH. So if you're given pH, how to determine concentration, you must be able to find all those things. And with this, I'm wrapping up the session. Please guys, subscribe to the channel, like the video, share with your friends who might need the session. Okay, so if you want me to tutor you, please use my number 07999 45460. Text me. We can now talk about me being your tutor. Okay, these are my numbers. You can WhatsApp me and I can give you other modes of communication. Alright, cheers guys, and enjoy your exam.